say x is equal to t squared minus 5, and y is equal to sine t. So let's do that. Okay, right away you should see this is going to be a parametric equation or set of equations because there's a t. So right as you see that, a light bulb should be going off in your head. Oh, this is parametric. That way you know kind of what formulas you're going to need. I am saying that it's on the interval from -1 to pi. So before we even start doing this problem, because the whole point of this is to find the derivative. So we're looking for what is the derivative. What I'm going to do is everyone take out your TI-84 calculator if you have it. I'm going to show you how to graph these on your calculator, because this could come in handy if we're allowed to use calculators on the test. All right, so first thing I want you to do, turn it on. Let's get rid of that. Turn it on, hit mode, and turn on parametric, which is like by the function right here, just arrow over and then hit enter. Okay, we're going to be going over polar next, but I just want to show you parametric for now. Okay, from here, hit y equals and get rid of this. And we are going to go with t squared minus 5. If you notice now, this if you hit x, what normally spits out an x, it actually spits out a t. Because if you look right here, it says like x comma t. That t is for parametric. So we have t squared minus 5. And then the other one, I want you to just do sine of t. Okay. Now I want to be on the interval from -1 to pi. Okay. So that means t can only be between -1 and pi. So I'm going to go to window here and then change my t min to be -1, I'm sorry. And then my t max to be pi. And then from here, I want you to do zoom and then zoom fit. So we want to zoom 0. And what it does is it fits it nicely to the screen like that. Okay. Now the thing about parametrics is you can't really tell what the graph is going to look like just by looking at these. I'm sure some people can, but it's not intuitive. You can't just go, oh, there's a quadratic and then there's sine. The graph's going to look like this. You have to kind of like graph it to actually see. And what you're doing here is you can see the little cursor down here. But t is equal to -1, but you can just change your t, and your x and your y are based on t. So as t changes, your x and y changes, and then it just graphs it on the xy plane. Okay. So we are looking for what is the derivative of this, because as you can probably imagine, there's ways of drawing tangent lines here. Actually, I'll do this here. Screen grab this. So let's do this here. Ooh. Okay, so I have this graph right here. What I can do is I can draw a tangent line wherever I want. So say I wanted to find the slope, the derivative at this point right here, I can draw a tangent line. So that means there's a derivative there. I can draw a tangent line here. I can draw a tangent line anywhere here. Okay, we are looking for the derivative, which will tell us the slope of all these tangent lines that I drew. That's the whole point of a derivative. It tells us all of these slopes. Okay, to figure out that derivative, we need to use that formula. So let's see here. We'll shrink this down a little bit. Okay, and you end up with something like that for the formula. Now we don't need any of this, so I'm getting rid of it. But we do need, this formula right here. Now the formula says find the derivative of y with respect to t. Okay, you should be able to do that in your sleep. So we're doing the derivative of this thing right here. So dy over dt. Okay, so we have that part of the formula down. Awesome. Okay, now we need to do this part right here. If you forgot what that means, what this d over dt means, it means take the derivative of whatever's after it. So in this case, there's a y here. I'll just put the y here. This means take the derivative of this with respect to t. So that's what I did. This is already with respect to t, so I did the derivative of that, which is cosine t. This one is take the derivative of x with respect to t. So dx over dt for this one is going to be equal to what? 2t. All right, so now we have this bottom part now. So we have this top part and this bottom part. To find the derivative, all you have to do is divide those two things. Cosine t all divided by 2t. And then you have your answer. This equation tells you the slope of any of these things right here. Any point you want, it's going to tell you the slope at that point if it actually exists, of course. So given that, let's find the derivative at some points. Let's see here. I'll just use the same points I guess I used for last class. I want you to find the derivative at the following points. So when t, emphasis on t here, is equal to pi over 2, 0, and pi over 4. Okay, so what essentially you're going to do is just plug in these t values to the derivative formula here. Okay, and this is kind of a good review for the unit circle because I'm sure some people might have forgotten that. All right, so if you plugged in pi over 2 here, to figure out the derivative at this point, you would just have to do cosine of pi over 2 divided by 2 times pi over 2. Okay, does anybody remember what cosine of pi over 2 is? 0, right? And then this cancels here, so you end up with 0 over pi. So the derivative at this one, I did not draw this very well, hold on. The derivative at t equals pi over 2 is equal to 0. Okay, now what this symbol means right here, it just means the derivative, and then you plug in t equals pi over 2. That's all this means. Math's a language, you have to translate it, the derivative, when you plug in pi over 2. So I did the derivative here, plugged in pi over 2, you get 0. Okay. All right, next, whoops. Next, we're going to do the same thing with 0. So if you plugged in 0 here, you get cosine of 0, which is what?
1.
1 over 2 times 0, which is 0. So you get 1 over 0. What is that?
Undefined.
Undefined. 1 over 0 is not 0. You cannot divide by 0. Okay, it doesn't make any sense. How can you divide something up 0 times? You can divide a pizza up 2 times, 3 times, 4 times. You can't divide it up no times. What does that even look like physically? Okay, so that's that one. Undefined. That does happen sometimes. By the way, check this out. If you actually plugged in, what was it, 0 for t? Let's go back to my graph here. So trace, and if I actually went to t equals 0, it doesn't go 0. Hold on, I'll just hit 0 and hit enter. Right there is where t is equal to 0. X is equal to -5, y is equal to 0. What do you notice about the slope of that point right there?
The slope is 0.
No, come on.
What?
Who is your Calc 1 teacher? That slope's not 0. I was this Calc 1 teacher. I'm insulting myself. What's the slope of that? It's a vertical line. What's the slope of a vertical line?
Oh my God, this is so embarrassing.
Someone said it. Someone said it.
Undefined, yeah.
Fine. You're dividing by 0. I have infinite slope. It makes no sense. Because you're not changing with x. If you're not changing with x, you're not changing in an instance, basically. That's why it doesn't make sense. You're infinitely climbing without moving over at all. So that's why it's undefined. And then last but not least, let's do, I guess we'll do blue, the derivative where t is equal to pi over 4. Okay, if you plugged in, what's cosine of pi over 4? Does anybody remember that one?
Root 2 over 2.
Awesome. Thank you. Okay, we're dividing this by 2 times pi over 4. Okay, so a cool thing happens here with 2 and this 4 cancel. The divided by 2 and divided by 2 cancel. So you're left with root 2 over pi. So I'm going to put something like that. Okay, boom. So that's basically all I'm going to be expecting you to do in regards to parametric equations. I found the derivative and I found the derivative at points. Found the general derivative. That's what this is right here. This will give me the derivative at any point, and then I actually used it on some of the points. Now check this out. Your calculator actually can find these answers out for derivative at a point. It can't actually find the derivative in general unless you have a special calculator. But check this out. Hit graph and then do second calc. The second option right here, dy over dx. 2, and you can write in, what was the first one? Pi over 2? Pi over 2, enter, and you get 0. Okay, it doesn't actually, it's right there. You can't really see it. Here, let's do this. Pi over 2. Enter. I still can't see. Oh, you know why? Because it's at the edge. Hold on. Let's do this. Let's change my y max to be, I don't know, 2. It's going to change the graph a little bit. And then pi over 2. There it is. Okay, what's funny about these calculators is that literally the technology has not changed since I was a kid, which was many moons ago. So the fact that you still have to spend $150 on these calculators is a joke. That's why I try to use Desmos as much as possible, but that's a whole nother story. But anyway, you see, if you notice right there, the derivative of that is 0 because it's a horizontal line. We did the vertical one already. I can try the pi over 4 one, but it's going to be a crazy, crazy number because of the square root. All right, so 0.450. 0.450. So if you actually do this, you should get 0.450. Blah. Hopefully, yes. Okay, good. Okay.